Hi guys, I'm Hari and today we will be talking about Hovercraft. So the description of the event, there's two parts to the event. There's a device that you have to build and a task that you'll have to take. For the device, you'll have to build a self-propelled vehicle that levitates or floats in the air that is powered by two motors to levitate and propel itself down a track so that it moves. The vehicle is scored on time and mass. So lesser time is obviously better and more mass, which causes it to sink to resist the levitating force more is better also. Testing. There will be a few generic topics such as Newton's laws of motion, kinematics, kinetic energy, and fluid mechanics, which are pretty much the physics of movement and how things would move, which relates heavily to how you will approach this event. So the parameters of the event, you can bring a 3-ring binder for the test. So this means that you can have notes, problems, concepts, and equations that you might need for the various test problems that you might experience or encounter. So it's a good idea to start taking notes and doing as many problems as you can that you stumble upon. And it's not necessarily better to cram your 3-ring binder with everything, like getting a 5-inch 3-ring binder and stuffing a textbook in there. It's better to have a few notes that are tabbed such that you know, which, if you are to refer to a specific problem that you encounter, such as Newtonian mechanics, like Newton's force, Newton's 3 laws of motion, you would flip to the page where you see the 3 laws of motion and the specific equations that you would need to use. There are various topics and problems, so you should be familiar with all the equations and concepts necessary to solve these problems once you encounter them. And Science Olympiad tends to be very vague in testing, so one competition might give you problems from Wikipedia, while another can give you problems from college physics or high school physics, so you should be as best prepared as you can. For the device, it's rather complex. There are lots of rules that relate to measurement and that you have to follow, such as the track, the device length, the device width, the track length, the track width, the boundaries of the starting and finishing line. And you'll have to trial and error to see the optimal mass, battery, motors, and material, which will be covered later on. And scoring is dependent on mass and time, with various competition violations possible, so if you have a competition violation, your score will decrease or have a factor multiplied down, so which is bad for you. So it is really important that you guys know the rules really well. Okay, so basically if you look over here, it shows you the track and how all the various measurements that are required, such as the starting line, the finishing line, the cushion barrier which the hovercraft will have to stop at, and then the entire track can be anywhere between 100 to 195 centimeters, and there will be a starting place and then a total width for the actual track. And there are construction requirements for the actual vehicle also, such as the 1/4 inch dowel so that it can hit photo gates, which will measure its time, and there will also necessary to be 30 to 35 centimeters above the vehicle surface, so it has to be 30 to 35 centimeters thick. And then you'll need to have batteries that are 9 volts, and brushless motors and integrated circuits are not permitted. The mass cannot be more than 2 kilograms. The length must be between 15 and 30 centimeters and cannot exceed 30 centimeters during the run. And competitors must also be able to answer the design, construction, and operation of the vehicle. So that means you really need to know how your device works, and you should be the one building it. For the test, there are various topics that are described here, which will be covered later on. So the vehicle testing, you'll have impounding, which means that you have to turn in your event, where the event supervisors or the judges will inspect your vehicle to make sure that it fits under all the conditions. Also, teams have a total of 8 minutes to adjust and repair their vehicle. So that means that when you get to run, so you have 8 minutes to prepare and set whatever you need to, such as your microcontroller, which you might use to program the motors, or making your testing to see that your motor works and having a trial run. And then you get 2 and you can make 5 failed or 2 successful runs, whichever comes first. So that means you once you fail 5 or once you uh, do 2 successful runs, then your 8 minutes finishes. And then teams may also be able to modify the vehicle during the impound period or their 8 minutes if time is available. So that may to like ensure that you can fit in the rules. So try to fit try to make sure your vehicle follows all aspects of the rules. So the track can also be between 100 and 195 centimeters, and length doesn't really matter as long as you should make sure to be able to reach that 195 centimeter mark, because there's not much points given on accuracy of the distance, and the target time is also between 5 and 25 seconds. So you have to reach the closer you are to the target time, the better score you'll get, which was explained in the scoring part later on. Okay, so scoring. So mass score is equal to mass of vehicle divided by the mass of the heaviest successful vehicle of all teams times 25 points. So the competition takes into account your vehicle and the heaviest vehicle. So the heavier you are, it is better, but it's also not preferable to have a heavy device that is really slow also, and that doesn't levitate. If it doesn't levitate, there's no point to this event. Time score. The time score is 1 minus the absolute value of the runtime minus the target time divided by the runtime's time multiplied by 25 points. So the smallest possible is 0 points, which is if you get as close as you can to the runtime. So you should try to get, so the target time will be given to you, and you should try to reach that target time and try to get the least possible score to win. And the final score is the mass score plus time score plus the test score. The test is scored like a regular test, and still affects your grade, your total competition a lot. For content in the test, there are lots of different topics, such as in Newton's laws of motion, there's inertia, force, impulse, force reaction. Inertia is the spread of mass around a specific object, which allows things to turn when things are rotating. Force is things that you experience every day that affect you when a mass or object is moving or accelerating, which is where the equation F equals ma comes from. Impulse is related to momentum, so your mass and your velocity will relate to how your impulse is. And force reaction is basically how, if two forces collide, and whichever force will win, or if one force collides, what will the opposite and equal force be? So kinematics is a study of motion. It's just a fancy name for that. So projectile velocity will be like an object that is thrown in the shape of a parabola, and you might be required to find position, velocity, and acceleration. Speed, acceleration, and position are related to each other. Speed is velocity basically, and position is where you are at a given time. Acceleration is the change in speed over time. Kinetic energy is one of the two types of energy that exist in physics, and kinetic energy is the energy you have while you're moving, which is related to the equation 1/2 mv squared. So m is mass and v is velocity. So that show and so the faster you are, the more energy you have, and the heavier you are, the more energy you have. And air cushioned vehicles and its applications. So there are various air cushioned vehicles and applications in the history, such as like blimps, helicopters, planes, and not necessarily planes, but things that are air cushioned, such that they use air to fly. So you have to know the history, design, and capabilities of these vehicles. Fluid mechanics. I really like this image over here, which I will show. Fluid mechanics definition. So this was a great slide that I found. So fluid is a substance that deforms continuously when acted on by a shearing stress of any magnitude. So it could be anything that can deform, such as water. It could be a fluid, or ink, or anything like that can deform. Mechanics is related to motion in physics, and fluid mechanics is the science of studying the mechanics of free moving particles. So, and there are various topics such as density, buoyancy, viscosity, Bernoulli's principle, Pascal's law. You need to know you need to know a lot about these topics, and so that you do well in the test. So you should do as many problems as you can, take notes, and excel. Device. You will have motors, batteries, propellers, and levitation. So as first of all, for material, it says you can use any material you want, but you want to be cautious between what material you use. Wood has a tendency to be heavy but not as sturdy. Metal tends to be heavier than wood, but it is much sturdier. And you should see this when you design your vehicle, what would be the best material to use. So motors, you can only use brushed motors, as it says in the rules, because you are not allowed to use brushless motors. And you should consider the torque vs the speed of the motor. Each motor gives you a certain amount of torque that you use to levitate or propel yourself, and you need to make sure that torque is enough for the mass of the vehicle that you're using. And the speed is related to the torque, as if the torque of the motor's high, the speed will be low, and if the speed is really high, the torque will be low. So you need to find the correct balance that ensures that your vehicle performs to its best capability. For batteries, there are 3 different types of batteries: LiPo, lead acid, and IMH. I would heavily advise that you use LiPo batteries, as they're light and they provide a lot of current and charge for its weight, compared to an IMH, which is rather heavy, and lead acid is really heavy. But LiPo is considered to be unsafe, but is permitted, and there are very few cases of it actually breaking down, and has a higher capacity, so you can expel more charge faster. So please go with LiPo batteries when you're building this vehicle. Propellers. So there are rules about propellers, and propellers can be anything. Like the propeller could be anything that you see in your fan that rotates or something like that. So shielding would be the thing that goes in the center, I believe, and that has to have a certain dimension. Over here it says that propellers must have shielding with holes less than 1/4 inch diameter. So with no less than 1/4 inch diameter, which the event supervisor must try to pass by passing a 1/4 inch dowel. So make sure your propeller fits that condition. And more blades is probably better, but you shouldn't have that many blades in a propeller. More blades will allow for better airflow and will ensure that you're faster. Okay, sample problems. So over here, I have linked a Dropbox which has taken and archived all previous physics tests that students have taken in Monte Vista Physics Honors class. So we will take a look at this Dropbox, and we don't need to focus on all the different units in Dropbox. Basically, we need to focus in chapter 2 and 3 and chapter 5. You need to be able to answer most of those problems without much difficulty. So over here, the slope of the acceleration vs time curve represents. So you would say it would represent. So slope of the units for acceleration is meters per second square, and for time is seconds. So it will be meters per second cubed, which is not velocity or position. So it will be the rate of change of acceleration. So you should take a look at these problems. These are multiple choice. So these would be free response. So this would be an example of a projectile motion problem. A gun is set on top of a plateau and is supposed to, and you're required to find various things such as the speed and the range. So there are various equations that you will use to help you, that will be helpful and beneficial, and you must understand all these equations and make sure you don't just blindly go. So these equations all relate to time, velocity, acceleration, position. So let's take a look at chapter 4, which is forces. so forces and momentum. This is an example of an opposite reaction forces. So it'll say A and B, balls A and B are colliding with velocity A, and then it becomes like that. So it says, so you have to choose between equal and opposite forces. So since these two go in a straight line, they would be an equal and opposite force. Here, this tension that relates to forces. So you'd see how, so you'll be asked to compare how the force relates to the first, second, and third block, and you have to acknowledge that there's more mass tugged by the first block than the third block. And over here, a problem: a force of 70 newtons is applied to a 15 kilograms, and there's static friction, kinetic friction. Static friction is the friction when you're not moving. So when you're not moving, the friction that's opposing you is static friction, but the moment you move, there's friction that's opposing the movement, which is called kinetic friction. And they are coefficients that reduce the speed of the object if it was moving in a vacuum instead. This will test your knowledge of the three laws of motion and how to apply it. So for taking a look at one more, you will probably need to know work and kinetic energy, which problems can probably be found this is still force, and oh, never mind. So over here you can see that this engine in a 2000 kilogram race car increases its kinetic energy at a rate of 300 kilowatts per 5 seconds. So this tells you that, so this is a problem of kinetic energy. So energy over time is power, and you know the final velocity of the car is 60 meters per second. So you can use 1/2 mv. I mean, this is power. So power is related to energy in terms of time. So you'd find the kinetic energy by getting this power and dividing by time, multiplying by time, and then you would find that would give you the kinetic energy. That's equal to 1/2 mv delta v squared. So you would just divide by mass and multiply by 2, and that would give you the vf minus vo squared, which would give you the initial velocity. So these are the kind of problems that you can probably expect on the test. Some might be harder, some might be easier. So you should go on Google and look as many problems as you possibly can do. Resources. Oh, sorry, I forgot to put the link here. So the physics textbook used in the physics honors class is a great resource to get the knowledge that you need for people that already don't know physics, or people that don't know physics yet. So that physics book is called cnx.org. It's a free online textbook provided by the Rice University, and you don't need to go through all the chapters, 30 chapters in this book. You only need to go to kinematics, chapter 2, 3, 4, 5, and 6, 7. So these all relate to the units that you'll find, but these are not all the things that you will find, such as you still need to know about the history of air vehicles, which can be found on Google, etc. Wikipedia is a decent resource, but you shouldn't trust on Wikipedia for all your information. So you should look at textbooks, which tend to be the best resource for information. So you can see that you get knowledge on what displacement is, which is position, which is position but different, because displacement looks at final minus initial position. Okay, so, and these are all the various units that you can find. You should know fluid mechanics, which is not, I don't believe, in this textbook, there is fluid statics. So okay, so there's chapter 11, which talks about fluid mechanics. So you should know density, pressure, but stuff like Bernoulli's principle and Pascal's law are not on this. So you would need to research on your own and figure out what those laws represent. And another great resource is the physics lectures that students watch in the honors class, which is from Mrs. 2. So she has tons of AP Physics 1 and Physics 2 and Physics C videos, such as for kinematics. So there's tons of videos that will be loading that are on YouTube for free to watch. They give you she gives you problems and explains concepts really well. But she talks really slow, so you should go double speed or 1.5 speed. Okay, do you guys have any questions?